convolution rule. That's the convolution rule. And the proof is the fact that that when matrices commute, the eigenvalues of the product are just these eigenvalues times these eigenvalues, because they have the same the eigenvectors are always the same here for all these circulants. So there's the convolution rule, that I can convolve and then transform, or I can transform separately and then multiply. So just maybe better write that, the convolution rule. Let's call it the C rule. Convolve, then transform by F, or transform separately by F, and then multiply pointwise. Element by element, component by component. Okay. So that's the convolution rule. And why is it so important? Because transforming by F, multiplying by the Fourier matrix, is extremely fast by the FFT. So it's useful because of the FFT, the fast Fourier transform, to multiply. Or to transform, whichever equal transform. Multiply by F. Transform. So it's the presence of the FFT that makes this, it gives us really two different ways to do it. In fact, which is the faster way? So we can produce the same result this way or this way. And if I don't count the cost of, if the cost of multiplying by F is low, because I have the FFT, which would you do? Which would you do? So let me just think aloud before we answer that question, and then we're good. So so my vectors have n components. So one way I can do is to do convolution. How many steps is that? If I take a vector with n components and I convolve with a vector with n components, how many little multiplications do I have to do? N squared, right? Because each of the C's has to multiply each of the D's. So that takes n squared. And Fourier is cheap. It's n log n. Log to the base 2. So the left-hand side is effectively n cubed. What about this one? How many to do these two guys? To find the Fourier transform to multiply by the matrix F. Okay, those are fast again. That's just, I've got two multiplications by F, so that's 2 n log n. And what's the cost of this? I have a vector with n components. Dot star vector, another vector with n components. How many little multiplications do I have to do for a Hadamard product or a component by component product? N, only n. Plus n. Yeah, I should have made that plus. Yeah, I had I had 1 n log n plus, it took n squared to find that vector, and then n log n. So it's so effectively n squared. But this one, where I do the n log n twice, and then it only takes me n more, so this is the fast way. So if you wanted to multiply two really big, long integers, as you would want to do in cryptography, if you had two long integers, say of length 125, 126, 128 components, to multiply those, you would be better off to separately take the cyclic transform of each of those 128 guys and do it this way. Take the transforms, do the component by component product, and then transform back to get that. Yeah. So it's the convolution rule is what makes that go. Okay. So that's. One more thought, I guess, about all this convolution stuff.